board. We are starting a new lesson, and I think that you guys will be very good at this. Now, we are talking about the transformation of quadratics. Before I even start, what in the world is a quadratic or a quadratic equation? What does that mean? No one? So people are saying, wait a minute, I know that quad means 4. Don't get caught up in that. A quadratic equation is anything with an x squared. So we'll have x squared plus 4x minus 3, something like this. So it is just a function or an equation where your biggest exponent's a 2. That's it. Okay? So when we're talking about transforming quadratics, we're going to really talk about this form tomorrow. We're going to go back to something that looks really familiar. I've got formal notes here on the next side. But if I give you a function that looks like this, my hope is that within 5 minutes, you guys all get this completely. So by the way, how has this been transformed? Can anybody tell me or just take a guess how this has been transformed? I'm gonna have to start calling on some people. Lucy, how has this been transformed, do you think? Up, down, left, or right, or what?
I don't remember.
Teresa, do you remember?
I mean, is it a parabola?
It is a parabola, but how has it been transformed? What do you think this does that minus 2 does to the x? What do you think it does? You think? Yeah, what,
right. Oh, sorry. Yeah.
It goes right to, and what's this do to it?
Up 3.
Up 3. So this is exactly the same stuff that we've been doing for a while, but instead of absolute values that make v's, absolute values make v's like this. This is a parabola that's going to make it's a U-shaped figure. Most of this stuff is exactly the same that we've already done. So this first part is literally a 5 to 10 minute lesson. Now we're going to concentrate on graphing this. By the way, what do you think if I put a negative in front of here? What's that negative do?
It flips the graph.
Yeah, it flips it upside down, or it reflects it over the x-axis, and that's it. So you guys already know everything about this. You just don't realize that you know it. So here's everything that I just said. A quadratic equation, it's just an equation where the biggest exponent is a 2. Quadratic functions, expressions, equations, they always make U-shaped graphs called parabolas. Now in the red, I just want you guys to be familiar with this. I need you guys to pay attention to details. Now, not so much today or tomorrow, but when we get through this, because they could be x equal equations or y equal equations. Well, I'm not trying to talk over myself here. This, for the most part, is what we're going to study. We're going to study them that look like this, but we're also going to address if it's x equals, well, that means it could either open to the right or they could open to the left. Now, that's more in our unit in second semester when we get on to conics. But if it's x equals, they'll open left and right. Why? Because x equals, well, x goes left and right. Y goes up and down. So if it's y equals, they have to either open up or down. Now, you won't have to pay that close of attention yet, but I'm just warning you, when you guys get into it, see it as information. Slow down and think your way through this. Now, you guys already know this, so if you need to write it down, write it down. If you want to take a picture, take a picture. If you already know this, then you are fine. So what we're studying today is vertex form and what this looks like. So A tells you about the quote unquote slope again. It's not really a slope, but it's telling you how steep it is or how compressed it is. Whatever goes with the H or with the X, which is your H, it's always the opposite of that, and that's going to be your vertex with your H coordinate. Okay, moves it up or down, the exact same thing we've already done. Now that's not an L, but that's an absolute value. So again, if A is greater than 1, it's going to be stretched. It makes it more steep. If A is less than 1, it makes the graph wider, which means if I had something like this, y equals 4, x minus 3 squared plus 1, this would move it right 3 up 1, and it's being stretched by a factor of 4. So it looks something like this, right? 1, 2, 3, up 1, stretched by a factor of 4. Oops, that's a terrible line. And it's not a V, now it's a U. If this were a 1/4, then for it to go up 1, it's got to go over 4. And it's going to be a really wide U. Okay, so that's what I mean. If it's shrunk or compressed, it's going to be much wider. If it is stretched, it's going to be more steep or closer together. If A is negative, it's reflected across the x-axis or it opens down, and that's it. Any questions? Does anybody need me to leave it on this page any longer? All right. So the last two things we are doing today, we are describing the transformation. So take a second and do these. Don't do the last one yet, but I want you to do 1 through 4. So take about 2 minutes and do 1 through 4. And if you think you've got those, if those are pretty easy, then do number 5. Number 5 is kind of a trick question. Take about 30 more seconds, and I want you guys to think about number 5, but maybe not do it yet. All right, so number one, describe the transformation. You can just say up, down, left, right, reflected, whatever it is. Who's going to do number one for me?
Is it left 3, up 4?
Somebody either verify or correct it.
Right. 3.
It's right 3.
Right. So why did you change it? I heard somebody or a couple people change it to right 3. Why did you change it to right 3?
Because a negative is to the right.
Yeah, you always have to do the opposite. Again, the thought process there is what value of x makes this equal 0? Well, what value of x would make the whole quantity here equal 0 would be positive 3. So that's really going to be right 3. So not left, but right 3. It's always the opposite of what you see here. So right 3, up 4. So what about number 2? This is going to be what?
Reflected over the x-axis, left 1, down 2.
Yeah, and let's say the reflection for last. So left 1, down 2, and reflected. Again, the order matters. And the reason the order matters is if I were doing this, which we'll do tomorrow, and I said, I want you to say it's left 1, down 2, and then reflected. So if it's the reflection that's last, in fact, you said it right. It's reflect. Sorry, I'm getting ahead of myself. It's reflected over the x-axis, then move left 1 and down 2. So you actually said it right. That was me that messed up. My fault. What about number 3, though? What is my vertex and what's the transformation?
Is it just up 1?
She said up 1. Somebody verify or correct. What do you think?
You can say up or left.
She said up or left. Now, I haven't really addressed this. So can I say up or left? Is it just up 1 or is it just left 1? Which is it? And look carefully to these two before we get to number 3. Again, it's easier for me to teach some of these things through an example than it is just to give you rules. So what do you think?
They're the same thing.
Anybody else? So I've heard from like 3
the
people
same
here.
thing happened.
I think it's up 1.
Tegan,
Because,
what?
like, I think it's up 1 because like the other ones are in parentheses, and that's like it's it's the plus, it's outside of the x like parentheses, and the square it's like behind the square.
All right, so I'm going to leave it at exactly that. So Tegan, you're right. So I haven't explained this yet, but how do you know if it goes with the x or if it's the h or the k? Well, remember, kind of like the absolute values, it has to be in that quantity. So the quantity that's being squared has to be with, that's your h. So really, this is like saying x minus 0 squared plus 1. So my vertex here, it's not moving left or right any, it's only moving up 1. Okay, so the left 1 you can't say there. My vertex would be the point 0, 1. Does that make sense? So if I go back to this page, here's the rule. Your h value has to be in the quantity that's being squared. So if you don't see anything there, then your h value is 0. Now, let's kind of put this all together here on number 4. What do we see for number 4? It's being what?
Shrinked.
Yeah, shrunk by a factor of 1/2, but I'm not going to say that here. Then it's moved. What's that minus 2?
Right
Yep.
2.
And then
Down 3.
down 3. All right, so number 5, what is different about number 5 than anything else? What's different about it?
Has no part.
There's a coefficient.
Yeah, inside the parentheses. So what do you think this is going to be? What would I have to do with this right here? And I'll just tell you, I have to square both. So this is really saying y equals 4x squared. So some people would say it's being stretched by a factor of 2. Some people that maybe were taught this in Algebra 1 might say, well, isn't that a horizontal shrink or a horizontal stretch? We're not really talking about horizontals right now. If you ever have a coefficient in the parentheses, go ahead and square it out. So 4x squared. So this is really being what? Stretched or shrunk?
Stretched.
By a factor of 4. All right. Now we've got about 20 to 22 minutes left here. Now we're going to talk about graphing, and I want you guys to start to figure out some things here. So I put these exact same things up here, and we're going to get a little more in detail with this tomorrow. Oops. So these are the exact same 5 problems that were on the other page. You can always graph this a couple different ways. You can always use your calculator. I'm going to show you that in just a minute. You can always make a table. But I want you to start before your pen or pencil ever touches the paper. Start by figuring out what should this look like. So you should be able to rattle off information right now. Does this open up or down?
Up.
How do you know it opens up?
Because it's a positive.
Because A is positive. What's my vertex on number 1? How's this been shifted?
4.
Wait, it's what?
Yeah. It's right 3 up 4.
That's right. So it's right 3 up 4. So as soon as you see all of this stuff, you need to see those transformations, know what that means. It's moving your vertex. And I already know that it opens up, so I should have a rough idea that it's going to look something like this. So that's right off the bat, that's what you should know. But I just said,
Wait, where's the slope that says it's positive?
that's your A value right here.
It's
So if
just one.
It's just 1, right? Now, we're going to really talk about the A value tomorrow. I want to kind of get you guys to discover that because these are U-shaped graphs. These aren't V's. So it's really even less than it's not near as much of a slope this time as it was in absolute values. So let's go ahead and make the table. Whenever you make a table, and we're going to kind of discover that A value, I need 5 points when you guys do this. Your vertex always goes in the middle. So what's my vertex? Positive 3, positive 4. Now we're going to talk a lot about parabolas in this as we move on. But when you're ever doing this, you must take an equidistant step, which means I can pick any value smaller than 3 and bigger than 3 as long as it's an equidistant step, which means if I go down to 2, then I have to go up to 4. But what if I have a fraction and I don't want to go there? Well, I could go down to 0, but if I go down to 0, then I have to go up to what?
6.
Because these have to be an equidistant step. I do not care which values you plug in, so use the ones that you think would be easiest. On something like this, usually the ones right next to it are easiest. So I am going to go with 2 and 4. Then I'm going to go with 1 and 5. Again, equidistant step, right? That's 2. 1 is 2 away from 3. 5 is 2 away from 3. That's equidistant. Now, what I want you guys to see is, and we'll talk about this a lot on Monday, is that through this x value is an axis of symmetry. So it makes it an axis of symmetry means as long as I take an equidistant step, left and right, my y values will be the same. So these two values will be the same, and these two values should be the same. Well, what do you think is easiest to plug in, 2 or 4? Again, there's no wrong answer. In this equation, would you rather plug in 2 or 4?
Two.
Yeah, either way, we'll get the same thing because 2 minus 3 is -1. -1 squared is +1. And 1 plus 4 is 5. If I plugged in 4, 4 minus 3 is 1. 1 squared is still 1 plus 4 is still 5. So you only have to plug in one value. So here, I can either plug in 1 or 5. Let's go ahead and plug in 5. What is 5 minus 3?
2.
And 2 squared is?
4.
4.
And 4 plus 4 is 8. Now, we're not going to have to make a table after today. But I want you to see why, and it's not a trick, why the A value works. So from 3, 4, my next point's 2, 5. And my next point's 4, 5. Oh, by the way, will somebody tell me again, what's my A value here?
1.
1. Okay. So if I took one step over, I went one step up. Well, what if I took 2 steps over? So I got 5, 8, and 1, 8. How far is that from the vertex, the y values? I went from 4 to 8, so how far is that?
Four.
Yeah, it's just 4. Let me show you one more. What if I put another point up here? So if I put like 6 and 0, if I plug in 6, 6 minus 3 is 3. 3 squared is 9 plus 4 is 13. So if I took, and I'm all the way up here at 613, right? So how many steps did I take from here to get to 13? Well, the answer is 9. So with the A value, if I went one step over, 1 squared means that's how many I go up. If I took 2 steps over, square it, I go up 4. If I take 3 steps over, I square it and I go up 9. So that's really how you do this. So after today, I don't want you making a table at all. I'm giving you kind of a sneak peek on how we use the A value. Now, I'm not really going to use the table on number 2. I'm going to go ahead and use the A value, and I'll give you more formal notes on that tomorrow. Any questions on this one so far? All right. So let's go pretty quick on the first part with the second one. What's my vertex at?
-1, 2.
-1 what?
-2.
-2. And is this going to open up or open down?
Down.
Down.
Down. So we're going to kind of get ahead of ourselves here. So I'm going to go ahead and say my vertex is at -1, -2. I know it opens down. What's my A value?
-1.
-1. So because it's negative, I know that it opens down, right? Now, like I said, I need 5 points. You can always, always, always make the table. But I don't need to make a table. Because, again, my A value is 1, right? Or -1. So if I go left to right 1, what's 1 squared?
1.
It's 1. And it's negative, so I'm going to go down from the vertex. If I go over 2 from the vertex, what's 2 squared?
4.
So 1, 2, 3, 4. 1, 2, 3, 4. If I went over 3, 1, 2, 3. 3 squared is 9, so go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's how you graph using the A value. You do not really need to make a table. Make sure that this graph, this parabola, has a curve to it, not a sharp V. Tia Walker Evans. Does anybody know who Tia Walker Evans might be? I don't have that one. Does anybody have any clue who Tia Walker Evans might be? All right, I'm going to let them in. If we get bombed, I am so sorry. Hey, Tia, can you start your video for me, please? Tia Walker Evans, whoever just came in. All right, whoever just came in under Tia Walker Evans, I'm going to remove you. I need you to come in under your student name, please. Okay. All right, so that's how we do. Any questions about the A value? So you kind of have to know what this looks like, and then it all makes sense. Let's do number 3. What's my vertex for number 3?
0, 1.
And what's my A value?
1.
1. So again, I could make the table, but if I go over 1, 1 squared is 1. If I go over 2, 2 squared is 4. If I go over 3, 3 squared is 9. So I'd have to go up 9. There you go. This really starts to get pretty easy, guys. And I know somebody out there is afraid to ask a question. Don't be afraid. Any questions on where I'm getting this over 1, up 1? Whatever I go over, the square. So here's what I want you guys to do. Think about number 4. How in the world would I do it if it's just a little different? This is what we're going to focus on tomorrow. But I do want you guys to try number 4 on your own. I know that there's going to be some people that get thrown off here. This is the heart of what we're doing tomorrow. Somebody tell me what's my vertex.
2, 3. Wait, -3.
Do -3. Is this going to open up or is it going to open down?
Up.
It's going to, how do you know it opens up?
There's not a negative in front of the parentheses.
Exactly. So again, let's make sure we don't make any silly mistakes. So my A value is 1/2, right? Is this stretched or compressed? Or stretched or shrunk?
Shrunk.
It's shrunk, which means I know it's going to be wider, right? Now, again, this is math. We can't just slop something like this up here. So let me get rid of those. Here is how this works. Please, please, please pay attention. Can you guys all hear me? Pay attention. We're really kind of choosing our X values here without making the table. So if I move it right 1, you square that value. So 1 squared is 1, and then what do you do with the A? You multiply it by A. So if I go right 1, I go up 1/2. If I go right 2, what is 2 squared?
4,
And then 4 times your A value, what is 4 times 1/2?
2,
So if I go over 2, I go up 2. Let's do it again. What if I went over 3? What is 3 squared?
9.
And 9 times 1/2 is 4.5. So if I go over 1, 2, 3, I go up 4.5. 1, 2, 3, 4.5.
Are you going up from the vertex or from the last point?
From the vertex, always from the vertex. So if I went over 3, now I can verify this here in 1 second. If I went over 3, 1, 2, 3, 3 squared is 9. 9 times 1/2 is 4.5. So I have to go up 1, 2, 3, 4.5. Ooh, well, this put me, let's just verify this. That put me at the point 1, 2, 3, 4, 5, 1.5. So when I plug in 5, I should get 1.5. What is 5 minus 2?
3.
What is 3 squared?
9.
What's half of 9?
4.5.
And what's 4.5 minus 3?
1.5.
There you go. Now let's do this one last time. By the way, you guys, I'm going to change up how we're doing our assignment, especially for this chapter. So this chapter, we're going to only do about a partial lesson. I went ahead and assigned you guys your assignment for tonight, but it's not due till Monday. So we're not going to get all the way through this stuff until tomorrow. You can go ahead and look at it. Again, you've got 3 attempts at it. You can look at it and try it, but it's not due until Monday night. So I'm going to start giving you guys just an assignment 2.1 instead of having 2 or 3 different 2.1 assignments. This last one, remember, we had to multiply this out or square it out. So this is really saying 4x squared. What's my vertex on number 5? Am I going up or down any or left or right at all?
Is 0, 0?
Exactly, Raylan. So it's 0, 0. Now, how this works, one more time. If I go right 1, square it. What's 1 squared?
1.
Times my A value, which is
4, right?
4. If I go right 2, square it. What's 2 squared?
4.
Times my A value. 4 times 4 is 16. So I'd be way up here. That's kind of what that looks like. So that's why we need to understand the transformations, what's going on and what it should look like. And then it becomes pretty simple. Now, again, I'll give you some formal notes on this tomorrow. About how many ever steps left to right. That's when you square it from the vertex. And then you multiply it by your A value. That's how you can figure this out. But that's all kind of dependent on knowing that this is an axis of symmetry. So if I take one step left or right, square it, 1 squared is 1 times your A value. Okay? Any questions at all?
So we know that if it's a positive slope, it opens up.
Mm-hmm.
But like if it was a positive slope on an x equation, would it open left or right?
That is okay. So, and we're going to get there. So if x equals, if I've got x equals and your A is positive, so A is, and I'll just say positive, like y minus 3 squared plus 1. Now, I don't want to address this right now, but if it's x equals and your A is positive, then it has to open to the right. Because where is x positive? To the right. If it were negative, now you're talking about it opening to the left. Okay? And then your standard form is going to change, but we don't get to that until like late next week. I just want you guys to be aware that it's not always going to be the same, so pay attention to details. All right? Some people just glance and they think maybe it's been miswritten, but that's really section 2.3.
Are we learning how to graph it on a graphing calculator tomorrow?
It's actually real simple, and I'll show you right now. Now, you have to know this both ways. All you have to do is hit y equals. You can turn your plot 1 off. And why can you turn your plot 1 off? Because we're not dealing with those points in statistics, right? So I turn that off. And if I'm trying to do like, what was that one that was difficult? 1/2? So I do 1 divided by 2, parenthesis, and I can't remember what it was, but your x value is right next to alpha, x, and I think it was like
It was -2.
-2. So x minus 2, parenthesis, hit the squared button, which is right catty corner or diagonal from 7. And then what was it from there? +1?
Yeah, I think so.
I think so too.
It was -3.
Oh, it was -3. Okay, so -3.
Yeah.
So if you hit graph it, and you guys might see this. So what we want to do, and I'll teach you guys all about this later, is hit zoom 6. That's your standard graph. Zoom 6, zoom standard. And it should show you everything you need to know. Now, if you want to know even more, well, guess what? Hit second graph, and that's your table. So I'll teach you all about this on your calculator, but I don't want my table to start there. I want it to be back at 0. So hit second table set, table starts at 0. There you go. Okay. And there's your points, how you know what to do. So you can always check your answer, and I am focusing here on checking your answer with your calculator. You shouldn't even need your calculator. Your calculator is going to take you way longer than doing this by hand. So know your A value and how it affects it. All right. Bell's going to ring any second. Your assignment is not due until Monday, but I would go ahead and take a look at it. You've got about 20 questions due Monday. Have a great day, guys. You're welcome.